Hi, this is a video for section 9.1 reflections. So the whole chapter, chapter 9, is about transformations, and we've done a lot of this already, but we just haven't done it to the depth that we're going to do in this chapter. So hopefully a lot of this is somewhat familiar. We're just going to get into a bit more specificity. It's a fancy word. So we've talked about congruent transformations. We called them isometries. That was the other name for them. So now we're going to talk specifically about reflections and then how to draw them. So the first thing the book brings up is if you were to actually construct and create a transformation, a reflection, using, let's say, like a compass, actually. And how we would do that is that you would have to have first a line of reflection. Okay, that's the first part of the definition. And then the second part is this. In order to reflect that image across that line, what you have to do is create a bunch of lines that are perpendicular to the line of reflection. So notice these all have little right angles here. And then the last part of it is once you create those lines that are perpendicular to the line of reflection, and I almost kind of missed this, they have to go through the original points. So through point here, through point B here, through point C here. They go through that. Then what happens is you make each of those guys the same distance on the opposite side. So they're congruent. I should know the other way around, but 1, 2, and 3. So the key is if this guy is 5 away from the line, he's 5 away. This is 7 away from the line, this is 7 away. 2 away from the line, 2 away. And that's how you create a reflection actually in real life, is you have the line, make distances perpendicular to it, and then just go on the other side of the line the same distance away. Okay. So the first example we're going to have is the first one's in your notes there, is to figure out which one of these four figures here is reflected across the line in, or the way they say it is reflected in line in. But I always felt like it sounded weird that I always say across because that's what we're doing. So I'm going to hit the button here, make your guess, answer will pop up, and then we'll talk about it. Okay, so looking at your problem here, then I'll go to the screen because I can draw on this guy a little bit. Got to figure out which one of these four is the reflection. And the key to it really is, like I said, the definition. Checking to see if I draw a line perpendicular from a point to the line and go the same distance away, do I get the same thing? So like right here, it's pretty obvious it's not going to be A because C is only a couple millimeters away from it. There's not point C, the same distance away. If I look at B, if I look at point C, yes, there's a point that's the same distance away from it, but notice it's not point B on your sheet. I know, or not C. I know it kind of blurred out here, but this is point C. This is B prime. This would have to be C prime. Same thing here. Here's point B. Here's the perpendicular distance, but the point that's the same distance away perpendicular to it is not B prime. It's C prime. The one that works is C because D is this distance away here. I connect it, and really that's kind of what I always do to cheat real quick, is just connect the dots to their opposite dots and say, oh yeah, A and A prime, D and D prime, B and B prime, C and C prime. All of those are the same distance from the line, and they're all definitely right angles. So your answer for that one is C. All right, so that's just, again, general definition of a reflection, kind of general idea of how it works. So, yeah. Okay. All right, coming back now. The next thing actually is reflecting across lines you just can't draw. So I've got a little, or you can draw. So I've got a little, here we go, general reflection. Yeah, little kind of thing for you to show you how this again works. So here's my mirror line. It's a vertical line. So if I want to reflect it, I want this object to be on the other side of the line and flipped, like that. Okay. And I can always test that reflection by connecting the corresponding dots. And they should be, if I do this, correctly, and this computer program did it for me, okay, they should be perpendicular to that line of reflection, which they are, okay, and they should also be the same distance away, which is pretty obvious to see. And as I move this guy around, that happens as well. They stay perpendicular the whole time, and then again, if I could find the midpoint, actually, here's what I'll do. I can construct that. Where's construct midpoint right here. So I'll do the midpoint of each segment, and you'll see it'll pop up on the line because it's directly in the middle. Whoops. Whoops. There. Did I lose that? Come on. Oh, well, you can see enough that it got those 3 points right there for me. Okay, so on the next problem, then the question is going to be, oh, I'm sorry, I almost skipped one thing. It's going to be about, what would the graph look like if I reflected across the line. One more thing too, you might not have noticed, is the fact that when you do this, it's a mirror. So if A is on the outside here, A prime is on the outside on the other side. So if A is on the left, A prime ends up being on the right. If B is on the inside towards the line, B prime is as well. So it's reversed, but they're, again, that same distance from that line. Okay. So here's a couple examples from the book just about this to look through. They're going to reflect this across the line, x equals -4 and y equals 2. What I want to talk about is just reminding you that if it's x equals, it's a vertical line because all of the x values are the same. Right here, x is equal to -4. Right here, x is equal to -4. Here, x is equal to -4. So it ends up being vertical. Likewise, the line y equals 2. All of the y values are equal to 2. So 2 for y, 2 for y, 2 for y, and it ends up being horizontal. So you've got to remember that when you're doing some of these problems, that x equals is vertical, y equals is horizontal. Okay. So here's the next example for you in your notes. Given this quadrilateral, graph the reflection over the line x equals 1, which is this vertical line right here. Okay. So here's what it looks like. Let's see here. Where's my... There we go. Sorry. So here's our graph. Okay. So the first thing I have to realize, and I'm going to get rid of the other stuff around it real quick, is I need to be equidistant, all the points do, from this line here. So what I really need to do is count of how far away are they from the line. So let's start with point M because it's kind of off to the side. Well, it's 1 unit away, but it's 1 unit to the left, so I need to go 1 unit to the right of the line. There's M prime. Okay. K is 2 units to the right of it, so I need to go 2 units to the left. And that's K prime. Okay. J is 1 unit away to the right, so I need to be 1 unit away to the left. There's J prime. And L is 1 unit to the right, so it needs to go 1 unit to the left. L prime. And then just connect them. And there we go. And that line is now, that figure is now reflected across that drawing. Okay. And here's the book's drawing to make it look a little prettier. Okay. Now, the next, and really the rest of this section, is dealing with formulas, okay, of reflecting things across the x and y axis, and then across the line y equals x. Okay, so here's the x-axis reflection. The formula for this is you take the points x, y, and you just multiply the y coordinate by -1, or really you do the opposite of it. And here's a little kind of, again, I got a little computer program for that, x-axis reflection. Here's the original triangle. I can move it around, but notice every single time the x's stay the exact same. -8.43, -8.43. -6.43, -6.43, -2.29, -2.29. What changes are the y values. Okay? And as I move those along, again, the y values are what change, and they're opposites. So if I move this guy down here, all the y's are negative. Now all the y's are positive. Okay? So that's an x-axis reflection. Change the signs of the y's. Now, for a y-axis reflection, it does the opposite. All the x's get changed. All the x's here are negative, all the y's are positive. Notice it's the exact same points, but now they're all opposites. And as I move this triangle around, what happens is, again, they flip. Okay. And if I move them over here, they flip over there. Move them down here, they, maybe share a point or something like that, but that's how it works. Okay. So, there's the formula for that. How to reflect across the y-axis, do the opposite of the x. So here's the book's quick example before we do one real quick. Graph quadrilateral ABC, they did that for us. Here are the vertices, and then reflected across the x-axis. So if I'm going to do an x-axis reflection, that means the x stays the same, the y values all change in signs. So keep all the x's the same, 1, 3, 4, and 2, 1, 3, 4, and 2, and now change the signs of the y's. 1 to -1, 2 to -2, -1 to 1, -3 to 3. And there's what it looks like. Okay, now our first example of this is they're going to ask us to graph it. I'm just going to ask you to do it from the formulas, and then I'll show you the graph afterwards just for the sake of time, because otherwise it would take us too long to do this. But we have got LMNO. Here are the 4 vertices for it, and we're going to reflect its image under the y-axis. We're going to reflect it over the y-axis. So the question is, reflect the correct coordinates from point M. Well, they're doing all 4 of them, so LMNO as well. So the question is, which one of these 4 groups of ordered pairs is the correct one if I reflect this across the y-axis? Okay, so if we're going to reflect something across the y-axis, that means the formula is going to go from xy to negative xy. Okay, so I've got L, M, N, and O, and now I'm going to switch all their points to be their primes. Okay, so L, well, it's got a negative 1 to begin with. I went the opposite of that, so it's going to be positive 1. We leave y alone. M has a positive 1 for x, so I went the opposite of that. So we change that, leave the y alone. N, I have a positive 2. I want to switch the sign of that, so change it to negative 2, leave the y alone. And then here's O. It's weird. I should switch the sign of O and make it negative 0, but 0 is 0, so it stays the same. Okay. So I'm looking for the one that has 1, 0, which gives leaves A out and D out. Negative 1, 1. Up, that cancels out C because it's negative 1, negative 1, so it must have been point B. Okay. Which does match up for the rest of them. So let's take a look at what we have here in the drawing for that. Yep. There's B. All right then, last form to do then is over the line y equals x. And this is also just a formula, actually a really easy formula as well. So this is a pretty straightforward formula section. But, excuse me, so I've got the line y equals x here, okay, and here it is reflected over that line, and the formula for this is just to swap the x and y values. That's it. So switch them around. So A is at negative 5, 2, now it's at 2, negative 5. B is at negative 1, 4, now it's at 4, negative 1. Okay, and you can see it here. I've got again another little drawing of this. Notice A is at negative 4.11, 5.69. Switch that to 5.69, negative 4.11. And that happens as I move it all it ends up doing is just swapping the positions. C is at 1.32, 3.33, now 3.33, 1.32. So I just swap x and y. Okay, so here's our next example. Given quadrilateral EFG and has vertices at E, F, G, and H, reflect this across the line y equals x. And then we'll figure out which one of these is the right one. Okay, so we go back to the picture. Whoops, wrong button. Back to the picture. Okay. So if it's a reflection across the line y equals x, all I do is swap x and y. Okay, so we have E, F, G, and H. E is at negative 3, 1, so it should be 1, negative 3. F is at negative 1, 3, so it should be at 3, negative 1. G is at 1, 2, so I swap that, it should be at 2, 1. H is at negative 3, negative 1, so it should be at negative 1, negative 3. And now we see which one matches up with that. And we can see we can cut off A instantly. B is looking okay. No, sorry, B's not because it's 1, negative 3, not 3, negative 1. Let's knock out B. C has 1, negative 3, which we want. D has negative 1, 3. Heck, that was easy. All I had to do was look at point E. Okay, and we had 1, negative 3. F was 3, negative 1. G was 2, 1. H was negative 1, negative 3. All right. Okay. And there's what it looks like drawing-wise. Actually, that's not the right picture, is it? Oh well, we'll go with that. I think the book had a mistake. Okay. All right. Yeah. So. Last little summary then here, just to have you fill in one more time, because writing it down once more will probably make you remember a little better. Reflect across the x-axis, just switch the sign of the y value. Reflect across the y-axis, just switch the sign of the x value. And if you're going to reflect across the line y equals x, just swap x and y.